Okay, number 23, we're going to find the area of an octagon with a radius of 11 units. So I could give myself an octagon here, but I don't actually need one. Because with an octagon, the first thing I would do is I'd kind of find the center and draw the triangle I'm working with. So you don't need the entire octagon, you really just need the triangle you're going to be looking at. And if I wanted to make it a little bit skinnier, try to make it skinnier. Okay. I'll put this in blue so we can see that it's the same triangle we're talking about inside the octagon. It has a radius of 11. Radius is going to be from the center to any vertex. That's because if I take a circle, okay, with that center, my center's not exact there. Let's try that. There we go. So if I put a circle around any of the regular polygons, from the center to that vertex is a radius of the circle. So that's why we call that a radius. Okay, so I have a radius of 11. And that's all I have. So anytime you're given one number, a side length, a base, a radius, the height, which is the apothem, you need to use your central angle. So to find the central angle, we do 360 degrees divided by the number of sides. 360 divided by 8 is 45 degrees. So that means inside this angle is 45 degrees. Now, after that, I'm going to take 45 degrees and divide by 2 to get 22.5 degrees. So if I have a apothem drawn here, then this angle inside my small half of my triangle is 22.5 degrees. We'll label this height as the apothem. We're also going to need to find the base. So inside this right-hand right triangle, we can call this x, knowing that this entire length is 2x, which is the base. Okay, so x and x. If you want, you could just look at it as a single right triangle. That's easier. This is 22.5 degrees. This is 11, a, and x. So because we have an angle measure, it's not a special triangle. We're going to use our sine, cosine, and tangent ratios to help us out. So from the 22.5 degree perspective, we can say a couple things. We can say that the sine of 22.5 degrees is equal to the opposite x over the hypotenuse 11. We can also say the cosine of 22.5 degrees is equal to the adjacent a over the hypotenuse 11. And we can solve both of those. So I'm going to use my calculator and get those values. So for x, I'm doing 11 times sine 22.5, and I'm going to round x to approximately 4.2. For the a value, I'm going to do 11 times cosine 22.5. I'm going to round my a value to approximately 10.2. Now what I really want is I want the area of the blue triangle. So I need the base of the blue triangle, which is going to be 2 times x. So my base is going to be approximately 8.4 because it's 2 times x. Drew that in my octagon. Draw that in my blue triangle. The apothem is 10.2. That's the height of the blue triangle. And so the area of my octagon is going to be 8, because an octagon has 8 sides, times the area of a single blue triangle. Single blue triangle is base, 8.4, times the height of the blue triangle, which is the apothem, 10.2. Base times height divided by 2. Use my calculator to do all that. 8.4 times 10.2 times 8 triangles. Divide all that by 2. I get 342.72 square units. And that is an approximate answer because I've been rounding along the way.